Hello viewers, in today's session we are going to discuss a very important and conceptual problem from differentiation and functional equations, right? So here we have a mixed problem on differentiation and functional equation, and the problem goes like this. If we have a function f from the set of real numbers to real numbers, and this function is given to be a differentiable function, and f of 0 is not equal to 0, and f satisfy this equation, that is f of x is equal to f of x minus y times f of y for all xy belonging to the set of real numbers. And in addition to this, we are given that f prime of 0 is equal to alpha plus 1, and f prime of 2 is equal to beta plus 1. Then we have to find the derivative of this function f at minus 2, right? And here alpha and beta are not equal to minus 1, right? So let us see how we can solve this problem with the help of partial differentiation. So let us start with this equation, that is we are given f of x is equal to f of x minus y, f of y for all xy belonging to the set of real numbers, right? So let us first take x is equal to 0 and y is equal to 0, right? So we'll get f of 0, and here we have 0 minus 0, that is 0, and here we have f of 0. So we have f of 0 is equal to f of 0, and here f of 0 times f of 0 is f of 0 square. We can take f of 0 to the left hand side, so we have f of 0 and square, and this is equal to 0, right? Now taking f of 0 common, we have 1 minus f of 0, and since we are given that f of 0 is not equal to 0, so it implies that this factor must be equal to 0, that is f of 0 is equal to 0. So we have f of 0 is equal to 1, right? So the first step is to get the value of f of 0, that is equal to 1, right? So this is our first step. Now we can make use of the concept of partial differentiation to solve this problem. So the second step is to differentiate both sides partially with respect to x, right? So we'll take the partial derivatives of both sides with respect to x. So we have del of del x of f of x, and here we have del of del x of f of x minus y, and here we have f of y, right? So when we take the partial derivative, then we can treat this y as a constant. So here we have the derivative of f of x, so this is f prime of x, and here f of y is a constant because we are differentiating with respect to x. So we have del of del x of f of x minus y, right? So we have f prime of x, here we have f of y, and now first we differentiate f, so we have f prime of x minus y, and then by a chain rule we'll differentiate this factor, that is x minus y. So we have f prime of x is equal to f of y, f prime of x minus y, and here the derivative of x with respect to x is 1, and the derivative of y with respect to x is 0, because the y is treated as constant. So here we have 1, right? Okay, so now here we have this equation. So what we will do, we'll take x is equal to 0 and y is equal to 2, because we have to find the value of f prime of minus 2. So let us take x is equal to 0 and y is equal to 2 in this equation, so that we can get f prime of minus 2. So now taking x is equal to 0 and y is equal to 2 in equation 1, we have f prime of 0, then we have f of 2 and f prime of x minus y. So we have 0 minus 2, that is this expression, right? So f prime of 0 is given as alpha plus 1, and here we have f of 2 and this is f prime of minus 2, right? So f prime of minus 2 is now equal to alpha plus 1 divided by f of 2. So the value of f prime of minus 2 is equal to alpha plus 1 over f of 2. So now we need to find out the value of f of 2, so that we can get the value of f prime of minus 2 in terms of alpha and beta. So now the third step is to differentiate this equation partially with respect to y, right? So first we have differentiated both sides partially with respect to x. Now we'll differentiate both sides partially with respect to y. So now we can write del of del y, and here we have f of x, and then we have del of del y, and here f of x minus y, f of y, right? Now see, in the left hand side we can see that f of x is a function of x only, and here we have to differentiate f of x with respect to y. So we are now taking x as a constant, right? So the derivative of f of x with respect to y must be equal to 0, because when we differentiate partially with respect to y, x is treated as a constant. Now here we have the product of two functions and both these functions contain y. So we'll apply the product rule. So first we have f of x minus y, then we have the derivative of f of y, and then we have f of y and derivative of f of x minus y. So here we have used this result, that is d by dx of uv, where u and v are functions of say x. Then the product rule says that first we have u, then we have dv over dx, then we have v and du over dx. So now we have 0 here, f of x minus y, the derivative of f of y with respect to y is f prime of y. Here we have f of y, then the derivative of f is f prime of x minus y, and then by chain rule we have the derivative of x minus y. So we have 0, then we have f of x minus y, f prime of y. Here we have f of y, f prime of x minus y, and here the derivative of x with respect to y is 0, because x is constant, and the derivative of y is 1 with respect to y. So here we have 0 minus 1, so we have simply minus 1. So now we can take this negative sign over here. So now we have f of x minus y, f prime of y minus f of y and f prime of x minus y, that is equal to 0. So now we have this important equation. So now let us take x is equal to 2 and y is equal to 2 in this equation. So we have f of 2 minus 2, then we have f prime of 2 minus f of 2 and f prime of 2 minus 2, that is equal to 0. So this is f of 0, 2 minus 2, 0. Here f prime of 2, then f of 2, and this is f prime of 0, and this is equal to 0. Right, now f of 0 is equal to 1, so here we'll write 1. Then we have f prime of 2. Now f prime of 2 is given as beta plus 1, and here f of 2, and then we have f prime of 0, and f prime of 0 is given as alpha plus 1, that is equal to 0. So now we can write beta plus 1 minus alpha plus 1, f of 2 is equal to 0. So this is beta plus 1. Taking this term to the right hand side, we have alpha plus 1 and f of 2. So f of 2 is equal to beta plus 1 over alpha plus 1, right? And see, f prime of minus 2 is equal to alpha plus 1 over f of 2, and we have obtained the value of f of 2 in terms of alpha and beta. So f of 2 is the ratio of beta plus 1 and alpha plus 1. So let us substitute this value of f of 2 in this equation. So now f prime of minus 2 is equal to alpha plus 1, and f of 2 is beta plus 1 over alpha plus 1. So we can take alpha plus 1 to the numerator. We have alpha plus 1 over beta plus 1 times alpha plus 1. So this is alpha plus 1 square. Alpha plus 1 times alpha plus 1 multiplied together gives us alpha plus 1 square, and here we have beta plus 1. So the value of f prime of minus 2 is given as alpha plus 1 square divided by beta plus 1. So this is how we can solve these kind of mixed problems on differentiation and functional equations.